Hi everyone, in this video we're going to be solving polynomial equations and inequalities. To solve polynomial equations algebraically, we need to follow the following steps. Step 1, put equation in standard form. ax squared plus bx plus c is equal to 0. Step 2, we're going to factor the left-hand side of the equation. Step 3, we're going to set our factors equal to 0. And lastly, we're going to solve for x. Let's take a look at the first example on the next slide. Here we have x to the fourth minus 2x cubed minus 9x squared is equal to negative 18x. Now remember, we want to put it into standard form, so we want to add the 18x over to the left-hand side. So I'm going to have x to the fourth minus 2x cubed minus 9x squared plus 18x is equal to 0. Now, we want to factor the left-hand side. In order to do that, our right-hand side must equal 0. Now, notice there's a GCF in x to the fourth minus 2x cubed minus 9x squared plus 18x. The GCF is x. So we're going to pull out an x, divide each term by x. Then what I'm going to do, because I have 4 terms inside my parentheses, x cubed minus 2x squared minus 9x plus 18, I'm going to factor by grouping. So I'm going to group the first 2 terms together and the last 2. I'm going to take the GCF out of my first 2 terms, which is x squared, open parentheses, x minus 2. Then the GCF of my next 2 terms, negative 9x plus 18, is negative 9, open up parentheses, x minus 2. Notice that inside my parentheses, the binomial has to match, which it does, x minus 2, x minus 2. So I'm going to bring down my original GCF of x, put together the x squared minus 9 times x minus 2 is equal to 0. Notice here, I have x squared minus 9, which is a dot problem, a difference of 2 perfect squares. So I'm going to do down x. To simplify that would be x minus 3, x plus 3, times x minus 2 is equal to 0. Then I'm going to tee it off. So I have x is equal to 0, x is equal to 3, x is equal to negative 3, and x is equal to 2. I have 4 solutions. Next, we're going to solve quadratic inequalities algebraically. So in order to do this, the first thing we're going to have to do is factor. Then we're going to determine all zeros, or solutions, or roots. Then step 3, we're going to put the zeros in order on a number line. Then what we're going to do is we're going to test different values on the number line to see where the inequality is true. Lastly, we want to determine the solution, writing it in interval notation or inequality notation, and we're going to shade on a number line. So unlike solving equations, we're going to be solving inequalities. Instead of having, like our first example, 4 solutions, here we're going to have a solution set where we're going to have many solutions. Let's look at an example. Here's our example. 2x squared plus 3x is less than or equal to 20. Now, just like in the past problem, we still have to put our quadratic in standard form. So we're going to subtract the 20 over to the left-hand side. Now, I'm going to solve it like it's a regular equation, and then we'll go back and evaluate what the less than or equal than sign means in terms of the problem. So right now, I'm going to have to factor 2x squared plus 3x minus 20. Now there's no GCF, so what I'm going to do is the AC method. I'm going to multiply 2 times negative 20, which gives me negative 40. And I'm going to break down and separate the middle term. So I'm going to rewrite my 2x squared, rewrite my minus 20. What two numbers multiply to negative 40 and add to 3x? Well, that's going to be 8 and 5, negative 5. 8 times negative 5 is negative 40. 8 plus negative 5 is positive 3. So all I did was write 8x and negative 5x, rewriting the 3x is equal to 0. Now, because I have 4 terms, I'm going to use factor by grouping, group my first 2 terms together and my last 2. Pull out the GCF. So 2x times x plus 4 minus 5 is our GCF of our next 2 terms. X plus 4 is equal to 0. Bring down my coefficients. 2x minus 5 times x plus 4 is equal to 0. And of course, I'm going to tee off. So I'm going to get x is equal to, add over the 5 divided by 2. So we get 5 halves. And subtract the 4, I'm going to get negative 4. Now remember, because this is an inequality, we're going to draw a number line. And I'm going to plot my 2 points. So I'm going to have negative 4 and 5 halves, which is really 2.5. Now, because I'm going to get a solution set here, I need to test my values. I have to see where I'm going to shade. I'm going to get a shade inside or outside. Now, because I have a less than or equal to, I'm going to have closed circles at negative 4 and 5 halves because both of those solutions are included. Now I have to determine whether I'm going to be shading in between the negative 4 and the 5 halves or outside the negative 4 and the 5 halves. So I want to pick a test value. I always like to pick the test value in between. So in between negative 4 and 5 halves is 0. So I'm going to test 0. So what I'm going to do is I'm going to substitute 0 back into my original. So I had 2x squared plus 3x is less than or equal to 20. I'm going to test 0. So 2 times 0 squared plus 3 times 0, is that less than or equal to 20? Well, let's see. 2 times 0 squared is 0, 3 times 0 is 0, so is 0 less than or equal to 20? That's true. So if that's true, that means I'm going to be shading in between the negative 4 and the 5 halves. Now, technically, I could also be testing numbers outside, so I could test negative 5 if you want to try that. So if I did 2 times negative 5 squared plus 3 times negative 5 less than or equal to 20, is that true? So what would I get? I would get 35 is less than or equal to 20. That's not true. So we wouldn't be shading on the outside because that's not part of my solution set. And then since 5 halves is 2.5, I could test 3. So if I did 2 times 3 squared plus 3 times 3 to see if that's less than or equal to 20, that would be 27. 27 is not less than or equal to 20, so that wouldn't be correct. So that's why we shaded on the inside between the negative 4 and the 5 halves. So I can write this in 2 different ways. I can write this in interval notation where I have a closed bracket because negative 4 is included, comma, 5 halves, also closed bracket because 5 halves is included. Or I could write this in inequality notation, negative 4 less than or equal to x less than or equal to 5 halves. Those are 2 different ways to write. Try the challenge questions next.